The next thing that we're going to talk about is select case statements. So these are actually case statements. We recommend using these. They're a little better than if-then statements. So you'll notice in the script that we just did, we did quite a bit of if-then and else-if, and the other option that you can do is use a case statement. And what this does, it'll make an attribute and then it'll actually set it to something to be analyzed. So now that we've had the stimulus kind of checked by what the participant responded, after the feedback slide, we're going to now calculate an observation. So we're going to open up the trial procedure and drop another inline object after feedback. And we're going to name this the add observations and open that up. So with our summation object, we're collecting information, but we need to now add an observation to it. So you kind of think you have this bin or this value of the summation object, but what do you want to do with it now? So what we want to do is actually take the, and I'm going to put some comments in here just so you guys have this as a reference later. So in green, which is not factored in, we're going to have add the observation for the overall accuracy. So this is where we're getting down to kind of the main question that we wanted, was the overall accuracy. So to do that, we need to actually take the summation of total accuracy that we have already declared and set in our experiment, and we're going to add an observation. So to do that, I'm going to hit dot, and you'll see same thing, all the different statistics you can add, max, mean, minimum, but I'm going to add an observation of stimulus, stimulus dot, and then accuracy. So this is an observation that we're adding to the total accuracy. We want E prime to know that, look at the stimulus accuracy and set that for the total accuracy at the end of the experiment. The next thing we're going to do is add the observation for each individual prime type. Now this is where we get into the whole case statement thing, because if you would like, you can, for each prime type, write if then or those kind of statements, but we can actually just select a case statement using getAttrib, and we're setting the attribute, but we're basically getting the prime type attribute, which is already in our list of attributes. And if you remember, prime type we referenced here, it's in the list, prime type. So it'll take which prime is actually used. You'll notice with the prime slide, we're actually showing an image here, and it's referenced from, you know, the prime from one of these lists up here, if I can find it. Oh, here it is. So this is showing you the congruency that we talked about, congruent and incongruent. So that's what we had, the if-then statements, that if it's a word and it's green, it's congruent. If it's a if one is pressed and it's red and it's a word, then it's incongruent. So these are kind of tracking the hypotheses that we had. And prime type is here. This prime type attribute is going to pick the prime state and the prime color, and you'll see that the nested list here will do the prime state as either a text or an image, and then the prime color will also pull up you know, whether it's red or green. So that takes care of our prime type attribute. So we're going to reference that attribute here by using a case statement. And we're going to add an individual observation to each prime type. So the prime types are, we'll do the case for red image first, and we're going to do red image reaction time, which we've set as a summation, and we're going to add observation stimulus reaction time. And you'll see that that's basically adding, you know, letting E prime know to get the reaction time of the participant's response to the red image and setting it to the stimulus reaction time. And then we're going to do case for green image and green image reaction time dot add observation stimulus dot RT. So we're just doing the same thing, but a case statement allows it to be a little bit more summarized. The next case would be the red text, and we're going to do red text reaction time and adding the, oops, sometimes it's better just to do the drop down. Add observation, same thing, stimulus, reaction time. And the last one is the case for the green text. And green text reaction time dot add observation stimulus dot reaction time. And then, as always, we have to end our select case. So this is going to basically make an attribute called prime type. It's going to use that attribute prime type that we have set in our experiment, and it's going to have it either be a red image, green image, red letter, or green letter. And it's going to have it interact with the summation object to analyze it based on the condition. So this is how you would allow the prime type to be referenced, and I think I have an extra quotation there. That's why it's important to kind of generate each line of script to make sure you're not missing anything. But I think this is set up correctly now so that it can actually add this observation in the background after everything has been done in terms of the feedback given by the participant. So now we will go ahead and file save and go back to our presentation. And with select case statements, as I said, you can set case statements instead of using repetitive if-then statements to set an observation to be analyzed. So like we did, we have basically this prime type, and we're having it interact with the summation object. So we're taking each prime type, meaning the green image or the red image or the red text or the green text, and we're having that interact with the summation object. So what that means is we're allowing the summation object to add an observation and collect that statistic of reaction time. Now the next topic we want to talk about is writing to a text file. Now, before I get into the writing to the text file, which is basically the last kind of portion of this experiment, I want to bring to your attention the timing considerations that I mentioned in the beginning. And if you open up any procedure in your experiment, if you're not familiar with this procedure properties, you can double click on a procedure and go to the property pages up here in the left corner. When I click on that, there are only two tabs available for procedure properties, and you want to go to the Common tab. And you'll see here there's a way where you can name your session procedure or the procedure that you've opened. And there's also the script generation option that I talked about in the beginning. We do have an article and information on our website about generate pre-run, but you'll see that this is set to top a procedure. Now what that means is when this procedure is generated by ePrime, the objects, even the inline script, all of them will be generated at the top of it, meaning at the beginning of the procedure. So right when this procedure is about to start, all these objects will generate in the background. Now with script, as I mentioned, that's not what you want. You don't want the the inline scripts to start generating too early, because, for example, if you're changing the color or the text, or if you're evaluating the stimulus, you don't want the script to be generated too early. That can cause some designing issues and your experiment may not run properly. So you want to make sure you take this to before object run when script is involved. Now, top of procedure, if you have only objects and no script, that's a great way to help with your timing of your experiment, because it will allow all your objects, the movies, the videos, or images, to generate in the background, and they're kind of ready to go before the experiment has gotten to that object. But like I said, with script, you don't want them to generate too soon, because often generate is custom, script is generated to customize an object or to evaluate something in terms of data collection. So you want to make sure that only runs right when it's supposed to, which makes sense because you don't want the evaluate stimulus to occur at the beginning when the stimulus has not even been responded to yet. So please make sure your procedure properties have generate pre-run set to before object run. And you want to make sure that's set for all of your procedures. It's just good common practice. And the next timing consideration that I wanted to mention is pre-release. If you open up any of your objects and go to the property pages, you'll see in the duration input, if you're not familiar with pre-release, this is also similar to generate pre-run, that it will allow the next object in line to preload in the background. Now I have this set to 0 because we don't want objects to be loaded beforehand. For example, if you do stimulus and open up the duration, if I had this pre-release set to, let's suppose, 300 milliseconds, what that means is when the stimuli is shown to the participant, in the background E' will be loading or pre-releasing this evaluate stimulus inline for about 300 milliseconds. And you don't want this to generate early, because if you remember, we typed in some case statements or some if-then statements that need to check the accuracy or the response given to the stimulus slide. So with pre-release, you want to make sure that it is set to 0 when script is involved. And same with generate pre-run. We do have a great article on our website that gives detailed information about pre-release and the best settings for that, because if you are only using objects and you don't have any script in your experiment, then you can use pre-release, which is a great feature that allows movies or images to load in the background of E' earlier than when they're actually presented on the screen. So that helps with timing, but with script we do not recommend using it. The other timing consideration is we talked about debug statements. I had that in the other experiment, and I just wanted to mention it's good practice to actually comment these debug statements out when you actually are collecting data or running the experiment. These are just basically for error handling when you're designing your experiment or when you're practicing running it. When you actually are doing it for timing purposes, you don't want the debug statements in there. They can take up to a couple seconds. So yeah, you want to make sure that you either delete them completely out of the experiment or comment them out, because even if it's a 2 millisecond delay, that can cause some timing issues with your experiment. So just wanted to mention that as well. And now that we've got that out of the way, the writing to a text file is something that is pretty common, especially with specific types of research. If you're doing any neuro research or anything like that, it's a way to basically write your information to another file. So the questions I have here is, how do you set a value such as a summation that is collecting data to format it to %? And then how do you have the value print to a custom text file? And then the last question is, how do you open and close this file? So these are things that we're actually going to show you in the script that we're going to add. So I'm going to go back to the experiment that we've been designing, and we have so far declared our summation, we've set it, we've allowed it to evaluate the stimulus with some specific information regarding the trial type being either easy, moderate, or difficult. And then we've actually added observations. We want to know the reaction time to specific prime types. Now what we're going to do is add just a teeny tiny bit of script to the end of the practice procedure. So this doesn't actually need to go on the test run. Basically, we just want to reset the summation so it's ready for the practice procedure. For the actual procedure. So to reset the summation, we'll go to the end of practice procedure, and we're going to actually drop an inline script right here and open, we'll just call that reset summation. And you'll notice that that did not go here on the actual trial procedure. This is something that we only need to set in the practice because we just we're not really collecting data for the practice run, so we're just going to reset the summation so it's ready for the actual test portion where it's collecting data. So I'm going to type in total accuracy dot reset, and what that does is just exactly what the script is written as. It's resetting the total accuracy to 0 so that it can be collected correctly for the test. So a lot of times people use this reset option because they want an observation to be added and they want to reset it or set it back to 0 basically every time it gets to this script. So now that we've done that, we're going to actually now look into the text file, write into a text file. So to do that, I'm going to go to the very, very end of the experiment. So we need to open up the session procedure. As you know, the levels of E prime, if you want something at the very end after the practice and test has completely ran all of its trials, you would want to do it on this main session procedure. So right before the goodbye slide, I'm going to add an inline script. So this is after all the practice and all of the actual test has been ran. And I'm going to call this the calculate summation. And I'm going to open that up. So now that we've added an observation and we've done all this stuff with the summation object, we can now calculate and do some kind of finalized data analysis that we can then present to our data file. And this will allow you to write the results of the summation object to a text file, as I mentioned, and this will be at the very end of the sample. So I'm going to put some comments in here to help with your reference later. So I'm going to take the value of this summation object and print it to the edat2 file. So if you're familiar, of course, edat file is for your, you open up an eData8 and you can port it into Excel and you can do a lot of data analysis with that. So this little bit of script is allowing the important value of the summation object that we've been calculating or gathering through the whole experiment to print to the file. And to do that, all you need to write is c.setAttrib. We're setting the attribute final mean, and you'll see that's not available as an attribute. That's why I'm setting it, and I'm setting it as a new attribute. Final mean accuracy, and closing that. And then I'm using the format function. Now you'll see when I type format, it turns gray, so that means E prime has recognized that. And if you go to eBasic help and you type in format, you'll see that there is information about the format function. And this tells you that it returns a string formatted to user specification. What that means is you can format anything that you really want. You can format different, an integer or a string, and you can change it by using the format function. So there's a lot of information in here about doing that. This is formatting currency, and there's %. It's just showing you all the different things you can do with format. So in our specific case, we just want to take the final accuracy, and you'll notice that we've taken the mean of the accuracy, which you can take any statistic that you may need, and we're going to format that to the by taking the total accuracy dot mean, and we're going to set it as a %. So using the format function, this is exactly how you would want to write it using these parentheses. So now that we've formatted it to the fact that we want it as a percent, I'm going to now take the value of the condition summations and print it e.2 file. So if you remember, we talked about the red image reaction time, and we're going to now let ePrime know to format that as well to the red image reaction time dot mean, and then set that to a percent as well. So in the first line that I actually took the final mean accuracy. I set that as an attribute and formatted that, letting ePrime know to use the total accuracy that we've been collecting as a summation, and basically format that mean to a percent and print it to the EDAT file. Now we're actually taking the values of all the conditions that we talked about in terms of the red image reaction time, and we're going to take that reaction time and do the same thing by putting it as a percent so that it's available in the EDAT file. So I'll do that for all of the different conditions that we talked about, the green image reaction, format, green image, rt.mean, and we'll do percent. And then the next one is c.setAttrib, red text, and format that to red text rt.mean and percent. So this is kind of where something copying and pasting would be helpful, but then you of course have to go through and just change the names of each object that you're referencing. c.attribute, now we're going to do the last one, which is green text reaction time, and we're going to format that as well to okay, hopefully I don't have any typos in there, but you get the gist of what is happening in this bit of script, that we're actually taking the value and certain conditions that we've been calculating, and we're printing it to the EDAT file as a percent. The next thing we're going to do is take, and you'll see that when if you're not familiar with commenting, you just you could either do it this way, or you can actually you make multiple comment lines as well. There's no, obviously, minimum to what you write. And you'll see if I do it this way, this allows multiple line comments. And then you can continue to type rather than having to do that for each line, but I'm only doing a little bit of comment, so I can do it this way. Now we're going to take the value of this summation object and print it to a custom text file. So we talked about printing it to the EDAT file, but now this is where we're actually going to do where I mentioned a lot of researchers will want to open up a different file and put the values directly onto that file during the experiment run, so that they can analyze it on their own if there's a specific file that they would want the data to be printed on. So to do that, you would just open up and use the write to text sample, and we use the open command, and use getAttrib to find the subject. Oops. And we're also going to get attrib the session number as well. So this just lets you access specific information that you want to be logged to that data file. And, oops, text for output as number 1. So that's allowing you basically to open the write to text sample, which could be, any custom file that text file that you would want it written to, and then you're going to get the attribute the subject as well as the session number, and it will allow it to output or print out as number 1 on that file. Then the next thing we're going to do is write column titles. And for that, you would just do print number 1, which is what we referenced above, and we're going to actually print that as the final mean accuracy. So it might seem redundant that we set it here to number 1, but this is how ePrime registers that this information should be outputted as number 1, and then this is going to print number 1 as final mean accuracy so that you can look in the file afterwards and know what value that is. Then we're going to open the file in append mode, and to do that we just print number 1 that we're referencing. Oops. And we're going to use c.getAttrib, and we're going to also do the final mean accuracy. And then you have to close the text file. Oops. And to do that, you just do close number 1. So this allows us to reference this, custom text file as number 1, and it's going to do the write to text sample and take the subject as well as session information. Then it will print the final mean accuracy, and then it opens the file in append mode to allow that data to be logged on that file, and then it closes it with this close command. And of course, as always, eBasic Help does go over this open and close method of writing to another file if you would like to see another example as well. But of course we do this right at the very end because we want to gather all the statistics first, and then when it's ready and set to go, we can format the information to the number that we would like to see, meaning a %, and then it will log it onto the file that we've specified. Now that we've done the write to text file, we can close that and save our experiment. As I mentioned, I cannot run the experiment because I'm recording, but I definitely recommend pausing the presentation and going ahead and running it on your end. And if you have any questions, you can definitely contact a support consultant, and we can help you with any questions you may have with the script so far. Now, answering the text file questions, how do you set a value such as summation object to format it to %? So as you remember, we use the setAttrib to set the attribute, and then we use the format function and set the data to % using parentheses, of course. And how do you have the value print to a custom text file? That's where we use the open command to write to another file. Then we specify the column titles for print. So we wanted to let them kind of reference the column as final mean accuracy, and then we had to close the file. And then how do you open and close? That's using the close and open command.